The internal assembly is responsible for housing all 5 of the internal Roam electronics. The assembly encompasses 8 3D printed strongbacks and bulkheads you can see in the assembly here. They are all slotted together and then assembled with a set of threaded aluminum rods. Once assembled, you can mount directly to one of the pressure vessel end flanges. This allows for the prevention of any further movement during its deployment.
Yeah, this is our pressure vessel housing designed to protect the internal components while withstanding high pressure underwater environments. This is made from aluminum 6061 and 7075 anodized, which ensures durability, corrosion resistance, and a watertight seal. The flange and the end cap and the tube work together to maintain a structural integrity at depths up to 350 meters. Here is the flange, which provides a secure watertight connection with dual O-rings to maintain a pressure resistance. The end cap attached to the flange seals the housing while integrating connectors to power and data transmission to the inside of the tube. The tube forms the main structural body, designed to endure high external pressures while protecting internal electronics.
Alright, now looking at the externals, we have 2 mounts that attach the tow cable rigidly to the pressure vessel. We have a rear connection to attach the tow array to the pressure vessel and keep it waterproof and keep the cable safe. And then we also have 2 transducer mounts. One is shown here, which I made myself. Looking at the mounts that rigidly attach the pressure vessel to the tow cable, we have the front mount here, which is just held on by some clamps and a mount itself, which is all going to be made out of stainless after the quarter ends. We have another rear mount, which again is the same logic with a clamp and then a stainless steel mount to hold it rigidly together. We have the connector piece, which will be hollowed out in the final iteration, again made after the quarter, but this connector piece mimics the real-life counterpart of the tow array it's going to be attached to on the rear of the pressure vessel. And then looking at the transducer mount, which also will be made out of stainless, it essentially is just 2 clamps attached to a tow array off the back of the pressure vessel, and then the transducer in a custom mount that we made, which will have a wire fed down into the pressure vessel.
This is the hydrodynamic end cap dome component, manufactured out of ASA carbon fiber plastic. It is separated into 2 halves for mountability around the S-tow cable, with 6 mounting points here, as you can see, configured with hex slots on the back end and insert screws on the front end. And this is mounted directly to the end cap via 6 mounting screws on the base, as you can see here.
This is the other transducer mount, transducer M27, that will be further down in the tow array. Its platform is made of stainless steel with the clamp that clamps onto the tow array. On the platform base, it will be threaded, which secures the transducer protective cage and transducer itself. The cage is made up of standoffs and laser cut bases that make up the cage to allow for the least amount of acoustic interference. The clamp, the cage, and the threads that will be placed on the platform itself.